Most modern circuit breakers are ambient temperature compensated. This means that the tripping point of the breaker is not significantly affected by changes in the surrounding temperature. Circuit breakers typically have two main elements. Firstly, the tripping element. This element is designed to heat up when current flows through it. When the current exceeds a certain threshold, the tripping element heats up enough to cause the spring-loaded mechanism to trip, opening the circuit. Secondly, the bimetal element. This element is also designed to heat up, but it does so due to the surrounding temperature. As the ambient temperature increases, the bimetal element bends, counteracting the heating effect on the tripping element. The tripping element and bimetal element work in opposition to each other. As the tripping element tends to lower its tripping point due to external heat, the bimetal element provides an opposing force that stabilizes the tripping point. Ambient temperature compensation is important because it ensures that circuit breakers operate reliably even when the surrounding temperature varies. This prevents nuisance tripping or failure to trip when necessary. While most circuit breakers are ambient temperature compensated, there may be some exceptions. It's always best to consult the manufacturer's specifications to confirm the temperature compensation capabilities of a specific circuit breaker. When current flows through the tripping element, it generates heat due to the electrical resistance. The amount of heat generated is proportional to the square of the current. If the current exceeds the breaker's rated amperage, the heat will eventually cause the tripping element to bend or to form, triggering the breaker to trip. The bimetal strip is made of two different metals bonded together, each having a different coefficient of thermal expansion. As the ambient temperature rises, both metals expand, but one expands more than the other, causing the bimetal strip to bend. This bending action is designed to counteract the bending of the tripping element caused by the heat from the current. The bimetal element is positioned in such a way that its bending opposes the movement of the tripping element. As the ambient temperature increases, the bimetal element bends, pushing back against the tripping element and preventing it from tripping prematurely. The degree of compensation is carefully calibrated to ensure that the breaker trips at its rated amperage regardless of the ambient temperature. Some circuit breakers use electronic components such as thermistors or integrated circuits to sense the ambient temperature and adjust the tripping point accordingly. These electronic breakers offer even more precise temperature compensation than bimetal-based breakers. Circuit breakers are typically rated for a specific ambient temperature range, such as -40°C to 60°C. This means that the breaker will operate reliably within that temperature range. If the ambient temperature exceeds the breaker's rating, the temperature compensation mechanism may not be able to fully compensate, and the breaker may trip prematurely or fail to trip when necessary. It is important to select circuit breakers that are rated for the ambient temperature conditions in which they will be used. In some applications, such as those involving high ambient temperatures or fluctuating loads, it may be necessary to use specially designed circuit breakers with enhanced temperature compensation capabilities. These breakers may include features such as larger bimetal elements, electronic temperature sensing, or forced air cooling to maintain a stable operating temperature. In general, circuit breakers with higher amperage ratings tend to be more sensitive to ambient temperature changes than those with lower ratings. This is because the tripping element in a higher rated breaker is typically larger and more prone to heat buildup. Therefore, it is especially important to consider ambient temperature compensation when selecting circuit breakers for high current applications. Ambient temperature compensation is not perfect. There may still be some slight variations in the tripping point of a circuit breaker due to extreme temperature changes or manufacturing tolerances. However, the compensation mechanism is designed to minimize these variations and ensure that the breaker operates reliably under most conditions. Ambient temperature compensation is just one of many factors that affect the performance of a circuit breaker. Other factors include the breaker's interrupting rating, its voltage rating, its trip curve, and its overall design. It is important to consider all of these factors when selecting circuit breakers for a particular application. The National Electrical Code, or NEC, specifies requirements for the selection and installation of circuit breakers. These requirements include guidelines for directing circuit breakers in high ambient temperature environments. Section 310.15 of the NEC contains tables that provide ampacity correction factors for conductors based on ambient temperature. These correction factors can be used to determine the appropriate size of circuit breaker for a given conductor and ambient temperature. In some cases, it may be necessary to use a larger circuit breaker than would otherwise be required to compensate for the effects of ambient temperature. For example, if a conductor is rated for 20 amps at 30 degrees Celsius but is installed in an environment with an ambient temperature of 50 degrees Celsius, the conductor's ampacity may need to be derated. This means that the conductor can safely carry less than 20 amps. To ensure that the circuit breaker trips before the conductor overheats, it may be necessary to use a 25 amp or 30 amp breaker instead of a 20 amp breaker. However, it is important to follow the NEC guidelines and consult with a qualified electrician before making any changes to the size of a circuit breaker. It is also important to note that ambient temperature compensation only applies to the tripping point of a circuit breaker. It does not affect the breaker's interrupting rating. The interrupting rating is the maximum amount of current that a circuit breaker can safely interrupt without being damaged. If a circuit breaker is subjected to a fault current that exceeds its interrupting rating, the breaker may fail to trip or may explode, causing serious damage or injury. Therefore, it is essential to select circuit breakers with an interrupting rating that is adequate for the potential fault currents in the circuit. The interrupting rating of a circuit breaker is typically marked on the breaker's label. It is important to choose a breaker with an interrupting rating that is higher than the available fault current at the point of installation. Available fault current calculations are typically performed by qualified electrical engineers. In addition to ambient temperature compensation, some circuit breakers also have other features to improve their performance and reliability. For example, some breakers have a thermal magnetic trip mechanism which combines a thermal element for overload protection with a magnetic element for short circuit protection. Other breakers have ground fault protection which detects and interrupts ground faults to prevent electrical shock hazards. Some breakers also have arc fault protection which detects and interrupts arc faults, which are a common cause of electrical fires. The type of circuit breaker that is best suited for a particular application depends on the specific requirements of the circuit. Factors to consider include the load characteristics, the ambient temperature, the potential fault currents, and the desired level of protection. It is important to consult with a qualified electrician to determine the appropriate type of circuit breaker for a given application. Circuit breakers should be installed in accordance with the NEC and the manufacturer's instructions. They should be properly sized for the load and protected from overcurrents. They should also be regularly inspected and tested to ensure that they are operating properly. If a circuit breaker trips frequently, it may be a sign of an overload or a short circuit. It is important to investigate the cause of the tripping and take corrective action. Do not simply replace the circuit breaker with a larger one, as this could create a fire hazard. Circuit breakers are an essential part of any electrical system. They provide protection against overloads, short circuits, and ground faults. By understanding how circuit breakers work and how to select and install them properly, you can help to ensure the safety and reliability of your electrical system. In summary, ambient temperature compensation in circuit breakers is a valuable feature that helps to ensure that breakers operate reliably under a wide range of temperature conditions. By using a bimetal element or electronic temperature sensing, circuit breakers can compensate for the effects of ambient temperature and maintain a stable tripping point. However, it is important to remember that ambient temperature compensation is not perfect and that other factors, such as the breaker's interrupting rating and its overall design, also play a role in its performance. It is also important to follow the NEC guidelines and consult with a qualified electrician when selecting and installing circuit breakers. The ability of a circuit breaker to function correctly regardless of ambient temperature is critical in many applications. Consider a data center where equipment generates a significant amount of heat. Without temperature compensation, circuit breakers could trip prematurely due to the elevated ambient temperature, leading to disruptions in service. Similarly, in outdoor installations, circuit breakers are exposed to a wide range of temperatures, from extreme cold in winter to scorching heat in summer. Temperature-compensated breakers ensure reliable protection in these challenging environments. The design and construction of circuit breakers have evolved significantly over the years. Early circuit breakers were often simple mechanical devices that were not very accurate or reliable. Modern circuit breakers are much more sophisticated and incorporate advanced materials and electronic components to improve their performance and reliability. The use of bimetal elements for temperature compensation is a relatively old technology, but it is still widely used in many types of circuit breakers. Electronic temperature sensing and compensation are more recent innovations that offer even greater accuracy and control. The choice between bimetal and electronic compensation depends on the specific requirements of the application. Bimetal compensation is generally less expensive and more durable, while electronic compensation is more accurate and flexible. Regardless of the type of compensation used, it is important to ensure that the circuit breakers are properly tested and maintained to ensure that they are operating correctly. Regular testing should include verifying the tripping point of the breaker at different ambient temperatures to ensure that it is within the manufacturer's specifications. Maintenance should include inspecting the breakers for any signs of damage or corrosion and replacing them if necessary. In addition to the tripping element and the bimetal element, circuit breakers also typically include other components such as a handle or lever for manually tripping the breaker, a reset mechanism for resetting the breaker after it has tripped, and the housing or enclosure to protect the internal component. The handle or lever is used to manually trip the breaker for testing or maintenance purposes. The reset mechanism is used to reset the breaker after it has tripped due to an overload or short circuit. The housing or enclosure provides protection against dust, moisture, and other environmental factors. The materials used in the construction of circuit breakers are carefully selected to withstand the stresses and strains of normal operation. The housing is typically made of a durable plastic or metal, while the internal components are made of materials that are resistant to heat, corrosion, and wear. The contacts, which are the parts of the breaker that make and break the electrical connection, are typically made of a conductive material such as copper or silver. The spring-loaded mechanism that trips the breaker is typically made of a strong and resilient steel. The overall design of a circuit breaker is a compromise between performance, reliability, and cost. Circuit breaker manufacturers are constantly striving to improve the performance and reliability of their products while also keeping costs down. This requires careful attention to detail in the design and manufacturing process. One area of ongoing research and development is the use of new materials and technologies to improve the performance of circuit breakers. For example, researchers are exploring the use of new alloys and composites that are stronger, lighter, and more resistant to heat and corrosion. They are also investigating the use of new electronic components that are more accurate, reliable, and energy efficient. Another area of focus is the development of smarter circuit breakers that can communicate with other devices and systems. These smart breakers can provide real-time information about circuit conditions, such as current, voltage, and temperature, and can be remotely controlled and monitored. Smart breakers can be used to improve the efficiency and reliability of electrical systems and to provide advanced protection against overloads, short circuits, and ground faults. In addition to their use in residential and commercial buildings, circuit breakers are also used in a wide range of industrial applications. These applications include power generation, transmission, and distribution, as well as manufacturing, transportation, and mining. In industrial applications, circuit breakers are often subjected to more demanding conditions than in residential or commercial applications. They may be exposed to high temperatures, more vibration, and more corrosive environments. As a result, industrial-grade circuit breakers are typically more robust and reliable than residential-grade breakers. They are also often equipped with additional features, such as remote monitoring and control capabilities. The selection of circuit breakers for industrial applications requires careful consideration of the specific requirements of the application. Factors to consider include the load characteristics, the ambient temperature, the potential fault currents, the desired level of protection, and the environmental conditions. It is important to consult with a qualified electrical engineer to determine the appropriate type of circuit breaker for a given industrial application. Circuit breakers are a critical component of any electrical system, and their proper selection, installation, and maintenance are essential for ensuring the safety and reliability of the system. By understanding the principles of circuit breaker operation and the factors that affect their performance, you can help to ensure that your electrical system is protected against overloads, short circuits, and other electrical hazards. And always remember that while ambient temperature compensation is a valuable feature, it is just one of many factors to consider when selecting circuit breakers. Consider the voltage rating of the circuit breakers themselves. Make sure that the voltage rating is adequate for the system that they are intended to be used in. Over voltage of the circuit breaker, meaning using it in a circuit higher than the breaker's rating, will result in catastrophic damage. Also, remember that if a circuit breaker trips, don't reset it immediately. Look for the fault that caused the overcurrent condition and fix it first. Repeatedly resetting a breaker without addressing the cause can result in a fire hazard. Don't just replace a breaker with a higher amperage rated one. This can create a fire hazard by allowing too much current to flow through the wiring, potentially overheating it. Consult a qualified electrician to find out if there is something wrong with the circuit if the original breaker keeps tripping. Be mindful that if a circuit breaker feels hot to the touch, it's a sign of a potential problem. The circuit is likely overloaded or there's a loose connection that is creating too much resistance. The circuit should be inspected by a qualified electrician as soon as possible. In conclusion, ensure that all circuit breakers are properly labeled to indicate the circuits they protect. This is crucial for easy identification during maintenance or emergencies. Also, remember that circuit breakers are designed to protect both the wiring and the equipment connected to the circuit. Selecting the right breaker for the application is vital for safety. Be aware that there are different types of circuit breakers such as standard, GFCI arc-fault circuit interrupter, or size. Each one is designed to protect against different electrical hazards. Using the correct type is essential for safety and to meet code requirements. Finally, if you're unsure about any aspect of circuit breakers or electrical work, always consult a qualified electrician. Electrical work can be dangerous, and it's always best to seek professional help when you're not sure what to do.